classification problem. Okay. So we'll going with the understand with the logistic regression. Logistic regression, right? With logistic regression, we are going with the understand how the performance metrics are work, right? In the classification problem. So first, we draw binary classification. Okay. So that's we have data points. It is the binary classification, right? And this is the base fit line. Okay. That's we have a binary classification. Okay. This we have a binary. This we have a binary classification. So in that case, try to understand what is the first. Okay, this is binary classification and how the binary classification are useful to calculate the confusion. What is the confusion matrix? What is the accuracy, precision, recall, FV score? The all concepts we learn in this one video. Okay. So first we are going with what is a confusion matrix. Okay. Uh, First confusion matrix. Confusion confusion matrix. Before understanding the confusion matrix, we draw a data set. Okay, we draw a data set. That's the two feature, and one is the and that's the input feature. Okay, input feature, and that's the output feature. Okay, and this is the prediction value, predicted value. Okay, predicted value, predicted value. So in that case, let's start with the we have some data points. And after that data point, we have some points like output or actual output basically. This is a predicted output and this is the actual output. Okay, actual output. This we have a actual output. So let's output are 1, 0, 1, 0, 1, 1, 0, 1. And predicted output let's consider as a 1, 0, 0, 1, 1, 1, 0. That's we have predicted output, right? And there's some data point. So that's a actual output and it's a predicted output. So when we draw confused matrix, so we draw something like that. Okay, that's we have confusion matrix. In that case, there's a actual point, actual value, and these are predicted. Okay, this is predicted, and in that case, okay, this 1, 0, 1, 0. So when we will see in a actual output, the output is a 0 and 1. That it means they come somewhere here. Okay. So this we are increasing with the 1. Okay. Similarly, when second point is a 1, 0. 1, 0 is someone come here. Okay. That's a 1. And third one is a 0, 0. So this is a 1. 1, 1. So a point second is come here. And 1, 1 also that point. So we are increasing with a 1 value. Okay. So is a 2 point coming here. Okay. Similarly, when going with the 0, 1, 0 in the 0 1 point is come here. Okay. So this is the value of 2. And finally, 1, 0. 1, 0 is a that is the point. So this is a confusion matrix. Okay. Confusion matrix. Confusion matrix is a, on the basis of that confusion matrix, all you learn about the precision, recall, what is recall, beta school, accuracy, all these concepts are based on a confusion matrix, right? So, what is the confusion matrix? Basically very important to understand. When you draw, one more thing, okay. how the point are distributed and what is the fall. So when you draw that type of graph, so in that case, it's a true positive point. Okay, it's a true positive point. It's mean true positive is mean 1 1. It's mean that point. This means the your model is predicted right point predicted, right? It's a true output, right? Okay. And similarly, is a true negative. True negative, it's mean that's point. That also your model predict right. Or similarly, is a fall positive, and one more is a fall negative. That is a yeah, that's basically confusion matrix. Okay, and for a confusion matrix, when you predict your model right, so it's come here and then that continuously increases that point. Okay, that's the confusion matrix. Okay, so second one we are going with the what is the accuracy. Okay, what is the accuracy? So accuracy is simply based on formula. So accuracy is nothing but when you draw accuracy, true positive plus false negative. True positive, true positive plus true negative divided by true positive plus false positive plus false negative plus true negative. That's your accuracy formula. Okay. Similarly, we know we call the precision. So precision and recall. Okay. So the third, what is the precision and recall? We are understanding precision and second one are recall. Okay. So let's start. We have a one understanding first. Before that, we are understanding one concept that's the data set. Okay. So when you draw a data set, that's the imbalanced data set. Okay. Imbalanced data set. Imbalanced data set. In that data set, let's consider 90% are yes and 10% are no. Okay. So that is the imbalanced data set. In that imbalanced data set, the accuracy it will be 90% accuracy. Okay. The accuracy will increases from 90%. In that case, the accuracy will be 90% accuracy. Okay. But what is the problem behind it? Right? When you draw the accuracy, 90% accuracy is good. But in that case, the points are not predicted that point or a model are not considered as a minority point. They more focus on a majority points. That's why that's accuracy is 90%. But in that case, we can't use that accuracy, right? So for that, we have two things: that's the precision and recall. Okay, precision recall. So in a precision case, is a for when you talk about the formula, is a two positive divided by two positive plus one positive. Okay, draw confusion matrix and understanding how the affected that thing. The two positive, all positive, all negative, two negative. Right. It's mean when you draw a confusion matrix. So this the focus when you precision focus on this graph. Okay. And similarly, for a recall formula is the for when you draw the recall formula is the two positive divided by two positive plus one negative. It's mean that focus on that point. Okay. So for understanding that simple concept, that's a very interesting thing. In that case, question is when you draw the precision. Okay. So out of the actual value, okay. It's a in a this formula set out of out of all actual value, how many how many are correctly predicted. Correctly predicted. This formula set in a simple term, when you draw the precision, right? So in a precision case, in a precision case, when you draw the graph, so out of all the actual value, how many are correctly predicted? And similarly, when you draw false, in that case, out of all the predicted, out of all the predicted value, how many are correctly predicted? Correctly predicted. In that is the actual point. When the draw actual points, how many are correctly predicted, and when draw the predicted point, how many are correctly predicted. That's a concept. I hope you understand that concept. Okay. So question is when to okay. In that case, you understanding. Basically in imbalanced data set, you can't use the accuracy, right? Because there's some error of that model not predicted right in right way, right? So in that case, we use the precision and recall. But problem is when to use you precision and when you use a recall. That is the question. So understand one more thing. Let's going to understand the use case. Understand the use case. That's the mail spam. Okay, so mail is a spam, and who is a model also show a spam. So this is a good, right? That's case one. But what problem is when mail are not no, not spam, not spam, but the model show it is the spam. So these are a bad. So in that case, okay, understand with the graph. Okay. So in that particular case, you use the precision. How precision? Because you know understanding the formula and the concepts. So that is a better understanding with that. So is the let's start the spam, and it's a not. Okay, and similarly, that's the spam, and these are a not, and it's a pointer 1, 0, 1, and this is a 0. So this is the true positive, positive, false negative, and true negative. That's we have a formula, right? So and a precision that is mainly focused on a that points. Okay. So if the mail are not spam, okay, mail are not spam, but model predict that it is spam. Okay. So this is the bad accuracy. Okay. This is bad accuracy. It means the point error come here. So we want to reduce that point, right? When when the mail is a not spam, that's the actual point. Okay, actual point, not spam. It's still the model are that point, not spam, but the model are predict their spam. Basically, 0 and point, and point is come out someone here. So we want to reduce that point. Okay, In that case, we use the simply precision. But what happened in recall condition? When in a recall condition, let's understand use case of a recall. Use case truth is a diabetes. Because truth in a patient have a diabetes. Okay, that's the truth. And model predict does not diabetes. Okay, so model predict that's a basically bad. That's still bad actually. That's the bad way model predict, right? And similarly, one more thing is a truth is a diabetes, and similarly model also predict diabetes. So in that case, that's a good movie. No model predict right. That's a good thing. But one more thing is what happens in third case is the truth is the model are not diabetes, not not diabetes, but model predict that we have a diabetes. That is also bad, but not that much because in that particular case, based on the use cases depend on use cases, use the precision or recall. Understanding that case, in that case, the no diabetes basically the concept of no diabetes. It's mean when a person have no diabetes, but they go in hospital and check again. That's not that much problem. In that case, we want to reduce that. Okay, so in that case, that we have a coil and we positive, positive, negative, and true negative. So in that particular case, we simply reducing that point because you have a diabetes, right? But model predicts Hara, you don't have a diabetes. It means we reduce that point, right? And mainly focus on reducing that point because truth, what is the truth? You have diabetes, right? But you model predict you don't. So we focusing on reducing that point. So in that particular case, we use a recall. No, basically different use cases. You use the precision recalls on accuracy.